This book by Roger Musin is a good one on the basics, and you can get this digitally online. This book by Jobst Brot is a classic. I like this book by Gert Schroner. One of the interesting things in it is how he reveals that after having built many thousands of wheels, he discovered that he really needed a tensiometer after all. These are all good books covering the basics, and they may give you a little bit of a wider perspective, but probably won't advance your knowledge base a whole lot. Quite honestly, your best bet for more useful information about how to build wheels is going to be in this video, Master Wheel Building 2 of mine, which is available for digital download. It's got over 4.5 hours of detailed content on topics such as considering the wheel as a circular arch, measuring hub dimensions, measuring effective rim diameter, choosing lacing options, calculating spoke lengths, off-center rims, carbon composite rims, working with bladed spokes, a more accurate way to get nipples to a consistent starting point than the one I showed you, an in-depth discussion of stress relieving, and an in-depth discussion of spoke torsional windup, and much more. If you're really interested in learning how a bicycle wheel works at the detail level, this is the place to go. The bicycle wheel physics and engineering that I have been researching for over 2 years. I expect this to be published in the fall of 2016, and will have between 15 and 20 hours of digital in-depth content. Here are a few of the thousands of graphics and photos in the video. Let's take a look at the table of contents, which appears in Chapter 1. Then we have a number of chapters that deal with some basic scientific terms and a little review of some basic math. 5 mechanical characteristics of the perfect wheel. We look at some geometry issues with respect to building wheels. And then 5 chapters that deal with my testing of spoke tension, centripetal acceleration, the modulus of elasticity, which deals with how elastic spokes are, and then we have some load cell testing and 4 more chapters dealing with spoke elasticity and lateral wheel stability, deflection of rims from point loads, moment of inertia, angular and linear velocity, the total kinetic energy equation for a bicycle that deals with both the translational and rotational kinetic energy, a good rotational energy demonstration. Then we look at pedaling torque mathematics, 4 chapters that deal in great depth with acceleration, deceleration, and disc brake torque, friction, compression of rims, the timing of adjustments to wheels, 2 chapters on stress risers, 2 chapters on hubs and bearings, and now we have 2 chapters on carbon composite rims, some compression tests of rims, looking at the bicycle wheel as a spring, 5 chapters on aerodynamics, rolling resistance, nipple and spoke threads, different wheels for different situations, further study, and then 4 appendices. There are many thousands of animated graphics and hundreds of film clips, and if you look at my website, you'll see glimpses into this video and get a sense of my instructional method.